Okay, fine. Hi, students. Welcome to day 2 of TCS training. And let me just quick fix something. Fine. There was some few problem with the audio. Now I guess it's fixed. Okay. So yesterday we saw a few problem. Now let's continue with the next set of questions. So let me just copy and paste the question so that you guys will be able to read that. Okay, fine. That's the question for today. Okay, let me just read out the question out loud. So it says a chocolate factory is packing chocolates into packets. Fine. The chocolate packets here represents an array of n number of integers. Okay. So we got some n number of values because there is going to be an array of size n. The task is to find the empty packets. So empty packets denotes 0 over here. So it says 0 over here, right? So that means that's going to be the empty packet. And okay, fine. So n number of arrays, and we got some empty packets in it. Empty packets in the sense 0 indicates it's an empty packet of chocolate, and push it to the end of the conveyor belt, which is your array. So all we need to do is you need to find out number of empty packets, and that is number of zeros. So we can see I've selected this 0. So we got 3 zeros in this array. So all you need to do is push this 3 zeros to your end. That's what your question says. So your input is followed by n, which is the size of array, and followed by the number of data. So if zeros are present in your array in the sense, we are supposed to push it to the end. So push it to the end in the sense, we might be wondering end says whether it is like end in the sense it's supposed to be at the last. So 3 zeros, these 3 zeros will be placed at the last index, these 3 index. If 4 zeros present, push those 4 zeros to your last index. So now, so we got another example as well, 8, where your end value is 8, and these are all your array elements for those data. Right. So you can see your first output, right? So all the datas are present over here, and then all the zeros are pushed towards end. So now, for reference, let me just take this and copy paste it over here. So now you can see that initial array, compare with output and your initial array data. So if you can compare, you can see that zeros have been pushed, but you can see this 4, 5, 1, 9, 5. These are in order. Like we are not sorting it. We are not doing anything. These are just order. You can see 4 is present over here, 5 is present over here, and 1 is present over here, followed by 9 and 5. So the exact data, you are just pushing it front. If 0 is present, you are pushing it to the last. Okay, and sample input 2, we have another example, same. So 618. So no changes in 6182. So 6182, no changes, only zeros, you are pushing it to the end. So let's start with this. Let me make this as a comment. Right. So remember the question. First input is 8, and we followed by array elements. And if zeros are present, no changes in your array data. So don't sort it or don't swap with the data, nothing. Just if 0 is present, push it to the end. Simple as that. So let's start reading our input. So let's take size n. So n is an integer. So cast it into an integer, get your input. So after getting n, we have number of ways to do this. We can set 2 pointers. What do you mean by 2 pointer is, let's say I have numbers like 1, 2, 3, 4, 5, and followed by 0, and followed by 8, followed by 9, followed by another 0. So I can put a pointer over here at the beginning. Let's just say this is I pointer. I pointer starts from left. And next, let's say I'm going to put another pointer, which is j. So j is pointing towards your last index. So we know that zeros are supposed to be present in the left side of array, because we are supposed to present. We are supposed to keep zeros at the end and keep numbers at the beginning. So what I'm going to do, I'm going to check. I is supposed to be a number. So I suppose I is a number. We don't have a problem. Move forward. So I just moves forward. Now check with j. If j is not a number, then we need to swap. But in this case, j is 0. Which means it's in the position. It's in the leftmost end. So what I'll do is I'll decrement j as well. So j now will be pointing towards this. Now what happens? Whenever there I, so I another number again, I'll push it forward. I goes to 3, another number again, and then I'll push it forward again. I goes to 4, I goes to 5, I goes to 0. Now we have a problem. Why? Because initially my j is over here now. Because you can see j is in the left side. Left side is supposed to be 0, but left side is a number. Now you have right side. Right side, if you have a number, we don't have a problem. But in right side, we have a 0 over there. So what we need to do? 0 supposed to be on the left side and the number supposed to be on the right side. So you can just swap these two data. So I'm going to swap I with j. So 9 will come here and 0 will go over here. So this will work. This will work if your test cases are like this. But if you have more number of zeros, let's take another example. Let's take I have a 0. Okay, this is original data. Let's say I have a 0 over here, a 0 over here, 0 over here, and 0, and 8 is placed over here. And then let's take another data, 9 is placed over here. So now what happens? Let's follow the same idea. So this is your original data. I'm going to keep it over here. And then I'm just copying and pasting it. So now your I pointer starts from 0th index. Now I'm putting another pointer j, which starts from last index. Fine. So as per the question, all the j value supposed to be 0 and all the I value should be a non-zero data. So that we'll be able to easily, if that condition doesn't work, all you need to do is swap these data. So I'm going to check with I data. So I data is a non-zero data. So we don't have a problem. I'm going to push I forward. So j is still pointing towards 9. Now what happens? J is a non-zero data. And you can see I is a 0 data. So what happens? This 0 supposed to be on the left side, but 9 supposed to be on the right side. So what I'm trying to do, I is non-zero, j is I is 0, but j is a non-zero data, which is 9. So what do you need to do? This 9 supposed to go to your right side. So I'm going to swap these two. I'm going to swap I with j. So this will become 0, and this will become 9. So if I do this, what happens? According to the question, the output supposed to be 1. Let's say, let me write output over here. So according to the question, first output should be 1 and second output supposed to be 3. But if I do swapping, if I maintain 2 pointers and if I swap, instead of 3, I'm getting 9 over there, which means that if you maintain 2 pointer and if you try swapping it again and again, that will not work. We cannot maintain 2 pointer and we cannot just move, we cannot follow the algorithm for segregating zeros to one side and non-zeros to one side. So if the question were segregate zeros to one side and non-zero to the other side, then this will work. But in this case, what happens? 1 should be followed by 3 and then followed by 9 and then followed by 8 and followed by 9, and remaining zeros will be at the end. But if you try swapping those data, it changes, because if I swap first two data, first 0 with the last 9, then what happens? 9 will come over here and 0 will go over there. So 2 pointers doesn't work. So when you take the interview, The time is limited, right? We don't have much time. So you need to quickly come up with an idea, come up with a solution, and try to optimize it. So if you can come up with the optimized solutions, that is way better. So let's think how can we do this. So now, after getting in data, I'm going to read all the inputs. I'm supposed to read all the inputs, right? So let's maintain a list. So this list, or an array, I'm going to call this as an array so that it will be easier. So this array, what I'm trying to do is, initially I'll put all the data as 0. Of what size? Of size n. So this, what happens is, whatever your n size, let's say n size is going to be 6. What happens? Your all the array data will be initialized to 0, 0, 0, 0, 0, 0, 0. What I'm trying to do, I'm trying to create an array of size n, and I'm initializing all the data to 0 if your n size is 6. So let me just put in sample input and output so that every time I don't have to go back and take the input. So this is my input. So I'm going to copy this and pasting it just over the top. Done. So that's going to be my input. So these are all my input. So the initial size is going to be 8 for this. So what happens? I'm initializing 8 zeros. Every data is made to 0, 0, 0. So after this, what you can do is run a loop. So I'm going to run a loop for I in range. It runs for 8 times, starting from 0 to 8 times. 8 in the sense that's your n value which is coming in, whatever your input is. So it's just a loop is running for 8 times. And I have a list which is every data is 0. So now all you need to do is maintain another pointer. So I'm going to call another pointer j, which is initially 0. Why the purpose of this second pointer j is, I'll tell you. So now what happens? Okay, you don't need another pointer. Like, I'm just trying to add the data. Like if you go with index value, we need another pointer. But in case of Python, we don't need a index value. So now what happens? After running my loop for n times, read the first data. So let me call it as A, which is the data which is coming in. So I'm reading the first data of the array, which is 4. So I'm trying to read, which is going to be another integer input. Fine. Now after reading this A, check whether this A is not equal to 0. So if it is not equal to 0, in that case, what happens? It will directly go into your array data. So what I'm trying to do, so first input is going to be 4. So 4 is a non-zero data. Non-zero data in the sense it should directly go into your array. And second data 5. So 5 we don't have a problem. Directly put it into your array. If it is 0, don't consider it. 0 data, don't put it inside your array. Only the non-zero data. Whenever you run your loop and whenever your a value is non-zero, directly put it into your list. So how can I do this is maintain a j pointer. So now where this j pointer goes is my array of j. Initial j value is going to be 0. So array of 0, I'm going to store my data A. So first I'll read A goes to 0th index. And next, my loop will run. I'm reading the second input. Second input is going to be 5. In case of 5, 5 will go to the first index. But j is still at 0, which means that j should be incremented. So I'll just write j plus equal to 1. So whenever you're adding a data to j, increment your j. So j will go to next index. So next input is going to be 5. So 5 will go to first index. Next 0. For 0, I'm not putting any data because we don't need, because already I've initialized every data as 0. Now after this, you'll read 1. 1 will go to your next index, which is your third index, and 9 will go to your next index, one by one. It will just join the non-zero data at the beginning. Once this is done, try printing the array data. You don't need to worry about zeros. Why? Because at the beginning, I've initialized every data to zero. If the non-zero data comes in your input in the sense, I'm just adding it and j gets incremented every time when new data is added to your array. Okay, let me just compile this and I'll make this as comment. We'll check for errors. Okay, no errors. So I'll give my input. First input is 8, followed by 4, 5, 0, 1, 9, another 0, and 5, and 0. See, now you got your output, which is 4, 5, 1, 9, and 5. So all the non-zero data are adding at the beginning of your array. Zero data, you don't need to worry about shifting it. You don't need to shift it to the zero because by default, the remaining data are going to be zero. Now, if you want to remove this, if you don't want this comma and this square bracket because it's an array, right? In case of array, you'll get this list, right? So in case of list, you'll get this square brackets command everything. But your output says just the numbers alone. We don't need these things. So in that case, what happens in Python? You have something which is called an asterisk or a star. If you use that, what happens? It will separate all the data into a single tokens. So 4 will become a token, 5 will become a token, 1, 9. Every data will be separated one by one by one. In other words, it will take out all the commas and the square data. So let me just copy this input data and I'm running my code and I'm pasting it, enter. So now you can see how the square brackets and the comma has been removed. So the question is simple. All you need to do is put the non-zero at the beginning. And if it is zero, you don't worry about it because it's already all the data are zero in the beginning. That's why I'm initializing zero for the size. Fine. I'll just take a look at it, get this question inside your head, and then we'll go to the next one. Okay, moving on to next question. Let me take this out. And sorry about this, like, okay, fine. So the second question, let me just read it out. So Joseph is learning digital logic subject, fine. So which will be for his next semester. Okay. He usually tries to solve unit assignment problems before the lecture. Fine. So today he got a tricky question. So the problem statement is a positive integer. This the positive integer has been given as an input. So we got a positive integer as an input. So you don't need to like it's a positive integer. Fine. And then convert decimal value. So the positive integer is referred to as a decimal value because it says a positive integer has been given as an input and then convert decimal value, which means that so we are taking that positive integer value that is going to be a decimal value. And it says convert, which means it's going to be a question of a number system. We need to convert one number into another number. Value to binary representation. So given decimal value, you need to convert it into binary representation. Fine. Toggle all the bits of after the most significant bit, including the most significant bit. Okay, what do you mean by toggle in the sense? Toggle in the sense if we'll convert decimal to binary, right? So binary in the sense all we'll get ones and zeros, 1 0 1 0. So toggle all the bits in the sense you're converting once you get the solution. For example, let's take two, or we'll go with three. For three, your value is going to be 1 and 1, because for three the binary conversion is 1 and 1. Toggle in the sense you're converting that 1 1 to 0 0. One will become zero and zero will become one. So you're toggling all the bits of it after the most significant bit. So what do you mean by most significant and least significant is, let's take a binary value 1 0 1 0 1. So this is just a bit in 5-bit representation. So this last bit, this is going to be your most significant bit. You can see, but it's a 5-bit representation. All we need is only 5 bits. But usually it's not 5-bit. You'll be having extra zeros over here. You'll be having up to 32 bits, all these zeros. But these zeros usually will not consider, because you don't need the zeros which is in before the datas, but only this data will be considered for the number. But if you're trying to store it in a computer with all these zero, but we are just representing a number only with this one, it doesn't mean that all these zeros are not there, it's still there. So now, why am I talking about this is, this last bit will call as LSB, that is going to be least significant bit. And this bit, which is at the rightmost, that I'm going to call it as most significant bit. So that is LSB and this is MSB. That is this particular point, most significant bit, including the most significant bit. Print the positive value after toggling all the bits. Fine. So including this bit, toggle all the values. So all we need to do is take this. We don't need to worry about these datas. So all these datas, I'm going to take it out. So let's say just this is your binary, like the binary value that you're getting after converting a particular decimal value. So from this, all you need to do is toggle all the bits, convert to binary and toggle all the bits. So I'm going to toggle it. So 1 will become 0, 0 will become 1, and 0 1 and 0. That is going to be your output. Simple. And okay, that's it. That's the question says. And we have constraints. So what I mean by constraint is, you don't need to worry about n value. I told you, like, you'll be getting a n value, right? So that n value lies between 1 and 100, which means the n value doesn't go less than 1, or doesn't go greater than 100. So you don't need to worry about getting more number and converting that into a binary value. So it's just the numbers. The n value is going to be between 1 to 100. It can be anything between 1 to 100. So give an example one. It says input is 10. So for 10, our binary value is going to be 1010. So if you can't quickly derive this how 1010 came, take powers of 2. That will give you a simple solution. So let's take powers of 2. So what is the power of 2 is, let's take 1 0 1 0. So how to convert this is this bit. This is going to be power. So 2 power 1 is 2, followed by 1 2 4. Okay. This is going to be, okay, 1 2, followed by 4, followed by 8. All the powers of 2. So now we can see. So I got all the powers of 2, 1 2 4 8. Now in this bits, what are all the bits if I add? I'll get 10. These are just powers of 2, 1 2 4 8. So after 8, you'll be getting 16. So the decimal value that I'm trying to convert it into binary is 10. So from last, try to get all the numbers so such that the addition of those numbers will be 10. So you can see that we got 2 over here and we got 8 over here. So 8 plus 2 will give you 10. That's why we got 1010. Now we can see, in place of 8, place 1. In place of 2, place 1. So 8 and 2, that will give you 10. Done. So this is how you can just take the parse, add the numbers where you can get this decimal value, put 1 over there, the remaining bits are going to be 0. Okay, and the result is 5. So we are not printing, we are toggling it, and we are printing for that binary value, we are printing its according decimal value. So let's try toggling it. So first initially we'll get 1010, that is for 10. And then I'm going to toggle it. So toggle it in the sense it will become 0 1 0 1. So for 0 1 0 1, take the powers of 2. So this particular is going to be 2 to the power of 1, and this is 2 to the power of 2, and this is 2 to the power of 4. So it's going to be 1 plus 4, which is going to be 5. So we are toggling and then converting that toggle value to its according decimal value, which is going to be 5. So let's see how to do this one. So the explanation is given below over here. Okay, see the binary representation of 10 is 1010. After toggling, it will become 1010. Okay, bits 1010 will get 0101. For 0101, it's going to be 1 plus 4, which is 5. Okay, let me make this comment. Okay, now my input consists of a single integer value. You don't need to worry about anything. Hmm. let- Let's just take it as a small one. That's going to be an integer value. So cast it into an integer. So now you can run a loop, and you can take all the reminders, and you can create a string, and you can join all the data one by one by one by one by one in order to get the equivalent decimal value of that. Or what you can do is, let's say I want to count number of bits. How can you count number of bits? Is for a given an integer value. So given an integer value, number of bits is given by log. Just take log to that number of base 2 and add plus 1 to it. So remember this particular line. So take log of that 10 value, and I mean log 10 of base 2. If you take that, what happens, and add plus 1 to it, it will automatically give you the number of bits the n is going to be. So if n value is 10, the number of bits is going to be 4. And if your n value is 5, the number of bits is going to be 3. Because for 5, it's going to be 101. So how can you easily find out that one is just find the log of 10 with the base 2. So how this works is, let's say log this, let's take 10, and this has a base 2. So what's going to be our answer for this? So instead of 10, let's take another number, so that will be easier, 8. So what is going to be the answer for this is 2 to the power, what will give you 8? That's how we'll find out. So 2, let's say POW. So 2 to the power, what, some x value, let's take x value, will give you 8. That's how logarithm works. So 2 to the power 3 will be 8. Done. So we can easily understand it's going to be 3. So 3 plus 1 will give you 4. So we can easily understand, if I take the n value as 8, 8 is going to consist of 4 bits. Now let's try with 10. So let's take a data 10. So for 10, 2 to the power something supposed to give me 10. So what is going to be your x value? X value will be 3.334, something around like that. So 2 to the power 3.334, that will give you 10. And this is a decimal value, right? So in case of integers, decimal will be neglected. So still you will get 3. So 3 plus 1, still you will get 4 number of bits. Fine. Now let's try finding number of bits. Okay, let's keep this over here. So after this, I'm trying to find the number of bits. Okay, let me write it as bits. Hmm. Log. Okay, log is under math. Fine. So these are inbuilt function, a library function which is available under math. So math, you can just write log 2. So I'm going to take math log 2 of n value. So that will easily calculate the number of bits. And I'm printing plus 1. So whatever the data that is taking the log of it, plus 1 will give you number of bits. So let's try printing the number of bits. Because n value, like whatever the n value, it's supposed to give its respect bits. So I'm going to write it as bits. So let me give it as 10. Sorry, 10. Oh, sorry, for the import. I need to import the library file if I want to use logarithm. So now we are getting 4.3333, but we don't need this 0.3. I told you, right? 0.3 should be eliminated. We are getting 4 with the decimal value. So if you want to eliminate that one, all you need to do is cast it. So I'm casting this. Take log, cast it into an integer so that decimal points will be eliminated, and then add plus to it, plus 1 to it. That will give you the number of bits for a particular decimal value. So now let me try again with 10. Done. You'll get 4. So after finding number of bits, and why you're finding number of bits is for this. Let me give you another example. Print. There is a shortcut for toggling the bits. So let's take 5. Let's take the same example, 10, and I'm trying to do XOR operation with the data 15. Why with the data 15? So why am I doing this? Okay, let us see what's going to be our output. So I'm giving my end day 10 days as 10. See, directly you got your output as 5. That was the output we are trying to expect. So why this is happening is XOR operator we know. If same bits, you'll get your output as 1. If different bits, your same bit output is 1, different bits, the output is going to be 0. So now what happens? This 10, we need to find this 10 lies under what power of 2? What power of 2? What do you mean by that? What do I mean by that is, let's take power of 2. We got 1 and followed by 2 and followed by 4 and followed by 8 and followed by 16. So if you take this power of 2, we know that now we know that this 10 lies between these two powers, between 8 and 16. How this power is calculated is, up to number 1, you just need 1 bit. From 2 to 3, we need 2 bits in order to store. But from 4 to 7, not 4 to 8, 4 to 7, 3 bits is enough in order to represent those decimals in a bits. But starting from 8 to 16, all the decimal numbers, which is from 8 to 15, not 16, 16 just less than 1. So all the decimal numbers starting from 4 to 7. So all the decimal numbers starting from 4 to 7 consist only of 3 bits. And all the decimal numbers from 8 to 15, 8, 9, 10, 11, 12, 13, 14, 15, all these numbers can be represented only using 4 bits. After that, 16 to 31, because next part is going to be 32. So 16 to 31, we need to represent those with 5 bits. If you want to represent something, some decimal number starting from 16 and to 31 in the sense, that will give you 5 bits. We need 5 bits of memory. So we need to find out, we don't need to worry about the 16 and everything. So we need to find out this 10 lies between what? So we know that this 10 lies between the power of 8 and 16, 2 to the power, 2 powers, 8 and 16. So now, after finding this, take the last bit, because after 15, the next number is going to be 16, which means the 4 bit ends at 15. Because before this, I will be having these numbers 15, 14, 13, and then 11, and then followed by 10. And let me write 9 also. So from 9 to these number, this is your end number. So all these number will be represented in 4 bits. So what happens? Take the last number. Last number is going to be 15. So now perform XOR, whatever the input that you got. So the input that I got is 10. Take the last number, perform XOR with it so that the bit will be toggled accordingly. If you get like equal input 0 1 0, that will turn it to 1. XOR operation, the truth table, 0 and 0, that will give you 1, or different input 0 and 1 turns to 0, or 1 or 0 turns to 0, 1 and 1 it will. Okay, let's check what happens if I give 1 XOR 0. Okay, we have error over here. We give 10. Okay, so different input, it is giving 1. And let's take same input. So it's giving 0. So same input, 0. Different input, it changes. See, 1 and 1, it is giving me 0. But if you give different input, like 1 or 0 or 0 or 1, so in that case, your output is going to be 1 over here. So different bits, positive data, same bits, negative data. So all we need to do is, what is the end value of this 4 bits? We need to find that one. So how can you find that one is, we already know the bits value is going to be, always remember the n value is 10. Based on 10, we are just calculating. So based on 10, the bits value is going to be 4. So how can I get 15 from 4? You don't need to get 15. You need to get 16. You need to find the next higher power for the number 10, which is going to be 16, because for 10 is in near. The next higher power of 2 is going to be 16. We need to come up with this number. So how can you do is, let's take this value as P, because I'm just trying to find the higher power. So that is going to give, that is given by math dot power of 2 to the power, whatever the bits that you found out. So the bits is going to be 4. So 2 to the power 4 is going to be 16. But we need to calculate for 15. So how can you calculate? Minus 1 will give you 15. So all we need to do is take the number of bits. Number of bits is going to be 4. How will you find the next greatest power, which comes under 2, which is going to be 16? So all you need to do is 2 to the power 4, which will give you 16. Now this is going to give you another data as well. So another decimal data as well. So I'm trying to convert this into an integer as well. To convert this into, cast it into an integer. So now we got 15. So all you need to do is print XOR of my input and then the power that I calculated. Okay, let's try. N value is going to be 10, and I'm pressing enter, and your output is going to be 5. So take log and then add +1, that will give you number of bits. Take power of 2 to the power of that bits, that will give you the immediate next greatest power of 2. And minus 1 will give you, like, it will 2 to the power 4 will give you 16, minus 1 is going to give you 15. So easily you can just perform XOR so that you'll get your output. Right, let's try with the next input. So 10 and 5. Okay, only one value, 10 and 5. Okay, let's try another number. Let's take 5. So for 5, my input is going to be 1 0 1. And if I toggle this bit, it's going to become 0 1 0. So 0 1 0, in the sense my output is going to be 2. Sorry, not 2, 3. Sorry, is it 3? Okay, 2, sorry. This is going to be 1 and this is going to be 2. So just 2. So the decimal value is going to be 2. So let's try that. So I'm going to try with 5 and I'm getting 2, which means the bits are automatically toggled. Take a look at it. Just find log +1, that will give you number of bits. For that bit, find the power -1, that will give you the next data, the higher power data. For that, those two data, just perform XOR operation, you'll get your output. Just try to remember all this. Because you can see the first question we need to know coding, and the second question this is based on a little bit of mathematics is involved. So let's go to the next one. Let me take this out. Okay, fine. Okay, this question says Jack is always excited about Sunday. Fine. So it is his favorite day. Okay, Sunday is Jack's favorite day. And when he gets to play all day, okay, that's the day he gets to play all day, which means on Sunday, like he is allowed to play or he gets to play. As he goes to cycling with his friends, so every time, okay, that's why like this is his favorite day because he gets to play all day and he goes to cycling with his friends. Fine. So every time when the month starts, he counts the number of Sundays. Okay, we have a starting month and he's trying to find number of Sundays. He will get to enjoy. Okay, the number of Sundays he will get to enjoy. Considering the month can start with any day. Okay, month can start from either of 7 days. We have Monday, Tuesday, Wednesday, Thursday, right? So either of 7 days or so on. So follows Sunday, Monday, Tuesday, Wednesday, and goes on. So count the number of Sundays Jack will get within n number of days. So Jack will get n number of days. Fine. Okay, for example, let's take this example. So now it says first starting input is MON. MON in the sense we know that's going to be a string input because MON is a string. So input string denoting the start of the month. Okay, the month is starting from Monday. And then we got another integer data denoting the number of days from the start of the month. Fine. So it just says that the month starts from Monday and after 13 days, how many Sundays he can get? That's what we are trying to calculate. The month is starting from Monday, which means that every 7 days, I mean every after 7 days he'll get a Sunday. So now we have 13 days. So what happens? Month is starting from Monday. After 13 days, how many Sundays he'll get? That's what we are trying to find. So as you can see, the output is 2 because number of days he is going to get is 13, which you can easily find out. All you need to do is get the number divided by 7 so that you can get. But that changes based on the day of the month which is getting starting. I mean, what is the starting day of the month? Okay, fine. We got an explanation also over here. Let me just move up the screen. Okay. Fine. So the month starts with Monday. So the upcoming Sunday will arrive in next 6 days because it's starting from Monday. And next Sunday will be coming in next 7 days. Now you can see the data is changing. It's 6 days and followed by next 7 days and so on. But if the starting day is like, let's say it starts from Tuesday, the month starts from Tuesday. So then what happens? The number of days he'll be having remaining is 5. And after every 7 data, one will be added. One you'll get one Sunday after every 7 data. And likewise, if the starting day changes to Wednesday, that's WED. So now what happens? The number of days remaining after because it's starting from Wednesday, right? Which means after 4 days, he is going to get another Sunday, and starting by next 7 days. So your number of Sundays which is occurring is based on what is your starting day. And then it's calculated by plus 7, plus 7, plus 7. So we don't need to worry about 7. We can just take n value and divide it by 7. That will give you. But we need to worry about these remaining days. How are you going to calculate these remaining days? Because if it is Wednesday and the remaining days is going to be 4. So how can you calculate is Wednesday is the third day, right? So Wednesday is going to be your third day. And we know that week has 7 days. So all you need to do is 7 minus 3. So I'm going to take 7 minus 3. That will give me 4. So first data after 4 days, I'll get one Sunday, definitely. Then remaining data after subtracting these four with 13. So first we got 13 over here. 13. Let's take Monday. So Monday is going to be your first day. And then, because Monday is first day, right? So if it is Tuesday, if your input is Tuesday, that is going to be your second day of the week. So let's take for Monday alone. If we take for Monday in a week, we know we have 7 days. So 7 minus 1, which denotes Monday. That will give me the data of 6. So all you need to do is first 6 days is going to get one Sunday. So in my output, I'll print 1. Why? Because already I'm calculating this remaining value, which is 6. Now, after calculating this 6, one day will be added because immediately after 6 days, you'll get a Sunday. So that data subtracted. So 13, I'm going to subtract by 6. So 13 subtracted by 6, that is going to give you 7. Now we know every 7 days is going to get one Sunday, right? So 7 divided by 7 because of 7 weekdays. So 7 divided by 7 is going to give you 1. That one I'll add it with output again. So this is for remaining calculation, and then the remaining numbers just divided by 7 again, so that you will be able to get your output. If the day increases, let's say number of day. Let's take this example for now. Let me take, this is going to be a Tuesday. And Tuesday in the sense, that's going to be your second day of the week. So 7 minus 2. The remaining data will become 5. So this is Tuesday now. Remaining data will become, the data will become 5. Instead of 6, I'll subtract 5. Now let's take, instead of 13 days, let's take 14 days. So starting day is going to be Tuesday. We need to find out after 14 days, how many Sundays we'll get. Starting day, the month starts with Tuesday. Tuesday is the second day of the week. And after 14 days, we need to calculate how many Sundays will I get, how many Sundays I'll get. So now take this reminder. Why am I subtracting it by 2? Because that's the second day of the week. So 7 days, total 7 days, subtracted by 2 will give you 5. Now all you need to do is from 14, subtract 5. So if from 14, if I subtract 5, I'll get 9. So 9 divided by 7, still I'll get 1. Simple. So that one will be added over here. And this one, because of this reminder, because whenever after 5 days is going to get one Sunday, right? So that's why this one is always going to be a constant one. Because every 5, like if I subtract it, if I get a reminder, that will become 5. So I'm going to add for this calculation, because after 5 days, you'll get one Sunday. And for this calculation, which is 9 divided by 7, again, I'm going to get another Sunday. So this is going to be 1 plus 1. So let's take this as 19. So if I take it as 19 days, 19 minus 5 is going to be 14. So 14 divided by 7 will give you 2. So this data will change to 2. Now we have 1 day from the remaining, and then 2 days because of remaining days is 14. 14 divided by 7 will give you 2 weeks. And that is going to be 2 plus 1, 3. So now let's see how to calculate this in a program. Let me make this question as a comment. Fine. So first one is going to be an input. So I'm going to take it as day. So day is just a string input. You don't need to cast it, or you don't need to do anything. And then number of days. Number of days is an integer value. So I'm going to take it as an integer input. Done. Now we need to find the remaining days. So for remaining days, how can you find? And because we need to know whether it is, if it is Monday, I need to get 1. If it is Tuesday, I need to get 2. If it is next Wednesday, I need to get 3, because every day has its number, right? And then I'll take 7 and I'll subtract with that number. So day, I'm trying to make it refer to its number. So for that, what I'm going to do is I'm going to maintain a list. This list contains Monday, all the weekdays. So Tuesday, and then followed by Wednesday, Thursday, Friday, Saturday, and then Sunday. Done. So what I'm trying to do is I'm trying to match the numbers with the days because Monday is one, Tuesday is one, Wednesday and Thursday, Friday, all the numbers. Fine. Now, based on this, calculate this input. This input is matching with which index? Whatever the index it is matching, that index is going to be my number, right? And make sure Monday is first day, but your index value starts from 0. So which means that we'll take 6 instead of 7. Why? Because of index value starting from 0. Now let me write a loop. So I'm going to write for I in range of L. So length of L. So for this, we need to match. So let me give input. For this, my input, let's consider it's going to be Monday. So now, whenever the day matches with my I data, mark that value. Take that index value and mark it. So how I'm going to mark it is, let's take index. So initial index is going to be 0. We don't know what's my initial index data. Now, if my day matches with list of that I particular day, you can see I'm trying to match. So now this Monday is matching with this one. And if I give Tuesday, this Tuesday will match with the list of this index. And this Wednesday will match of third index, fourth index, fifth index, likewise. So I'm just trying to find out which index value that the user input is giving. So this time I'll just copy. I'll take that index and I'll copy I to it. So once the day is found, you don't need to run your loop again. So break your loop. So I'm just finding the index value of whatever the input the user gave. So user gave Monday. So Monday is at 0th index. So I'm taking 0 and copying it to index. So once this is done, calculate the remainder. So I'm trying to calculate remaining days. So remaining days, we know it's going to be 7 minus index data. Since index starting is from 0, I'm going to write it as 6. Because 7th day, the last index data is going to be 6. Or we can write this. We can write I plus 1. Then you can take 7 subtracted by index value. Because first day is going to be Monday and 0 plus 1 will become 1. Index value will become 1. Now we are calculating the remaining days, which is done. So after calculating remaining days, we have our end data, right? So end data subtracted with the remaining days. Because I told you, calculate remaining. For this remaining days, one Sunday will be added. And for this end data divided by 7, and you'll get another answer. So addition of these two will give you the output. So I'm going to take this reminder. Now, let's take after a count. So count is going to be n divided by 7. Done. So let's try printing it. So print 1, which is for this remaining days. Whenever you calculate remainder, I'm just one day will be added. So I'm going to write 1 plus the count. Because count is the remaining days divided by 7. That will give you the count. Okay, let's try running this program. So let's try with same input Monday and the number of days is 13. So now you're getting your output as 2. Fine, this works. We don't need to worry about it. Now let's try giving a different input. Let's say again the week is starting from Monday, but number of day is 5. So what I'm trying to do, if a month starts from Monday and we are counting only up to 5 days. So only up to 5 days, how many data will we get? We'll get 0 data. There is no Sunday. because the first day is Monday, and after 5 days, no Sunday comes. So I'm trying to press enter. I'm getting 0. Simple. So look at this code. So all you need to do is calculate reminder. For that reminder, just add 1 to it. And once you calculate reminder with your n value, subtract that reminder. So after subtracting it, then get your count value. So count value is given by n divided by 7. So remaining n values just divided by 7. You cannot directly do it. If you just like directly 7, like because of the starting day, this count will change. We need to eliminate that starting day. How can you eliminate that starting day? Just find the reminder, eliminate it by that particular index value. So just take a look at it. And we'll move on to the next one. Okay, let me remove this. Okay, let me just read out the questions. Okay, airport security officials have confiscated several items of the passengers at the security checkpoint. Okay, they have just got some items the from the passengers. All the items have been dumped into a huge box, which is an array. So you are given an array of some data. So each item poses a certain amount of risk. Okay, so now you are given an array. That array indicates some different item which is confiscated from the passengers, and that item has a risk. Those risks are given by 0, 1, 2. So 0, 1, 2 in the sense 0 in the sense the least risk, and the medium level risk, and the highest risk. So we have 3 risks according to the item. For example, like if you take let's say some plastics are not allowed, right? So plastic, let's say plastic, that the risk level is 1. And if you take a few more items, some items will be a risk level of 2. Some items will be a risk level of 0. These are all the risk levels of the different items which is given in your array. So yes, the risk security item are represented in an array. Fine. So n number of integer values. So first input is going to be size of the array. Your task is to sort the items based on their levels of risk in the array. So all we need to do is sort the data. Ranges from 0 to 2. Okay, all the data. So all the data in your array is going to be either 0 or either 1 or either 2. Just 3 data. You just need to sort it accordingly according to the risk level of those items. So input consists of 7, and those 7 data are 0, I mean 1. So first item is of risk 1, I mean risk level 1. Second item is of risk level 0. Third item is of risk level 2, and 0, 1, 2 follows. So element of 0 to array minus 1, while each element is separated by a new line. Fine. And then output, you can see output is just a sorted data. You are getting 0, 1, 1, 1, 1, and I mean 0, 2, 1 followed by 2, 2. So only 3 data. You just need to sort it 0, 1, and 2. You just sort it, you will get your output. Example 2, 10 data. You are given 10 data, and all the data, you don't need to worry. All the data is either going to be 0 level or 1 level or 2 level risk. And every data is given in your new line. And for this output is going to be the sorted data. So explanation, the above example is the input array of size n consists of only zeros, ones, and twos. So you can see that there is no more data, only zeros and ones and twos. According to that, we need to sort it. So this question is like you might be considering that this question is easy, right? Because all you need to do is sort. So let's try. So let's take this input of size 7, the first input which is given. So I'm going to copy it. Let me move towards the end. Okay. So just for the reference, I'm just copying and I'm just pasting it. So that these are going to be your array input. So first one is going to be in size of your array. So read the size of your array. So that is going to be an integer data casted into an integer. Fine. And then start reading your array elements. So create an empty array. Let's call it as a here this time. So empty array, and then run your loop for I in range of n just here. How do you add the elements to your array? Append. Okay, get an input first. I'll get a data d, which is going to be another integer input, and then add the data to your array. So for adding, we'll use append. Append is the keyword. Done. So one by one, you're just adding the data to your array. And now what you can do, you can do this. You can just write ar dot sort, and then let's try printing it. Print ar. And I told you, right, the output is going to print with square brackets and comma. And if you want to eliminate that, put a star. So I'm going to run. Now let me give the input. So first is an integer input 7, followed by 1, 0, 2, 0, 1, 0, 2. So see, the array is sorted. Simple. But you are not supposed to use this. You cannot directly sort it. Because of three data. We have three unique data. You can just sort. If you write sort, it'll work. But why it will work in the sense you'll get your output. But your complexity, one of the test cases is going to be time complexity, right? That time complexity will fail because everybody can do this. You can just sort, just call for sort and you sort it. The question is done. But what happens? We should not follow this one. We should try to optimize our code. Optimize in the sense reduce the time complexity rate. So whenever you are trying to segregate three unique data, now we have only three data. For only segregating these data, we have an algorithm which is called Dutch, DUTCH, Dutch National Bank. So this is like one of the algorithm that will use to move arrays, like sort your arrays when you have only three data, because we have only three data, either 0 or either 1 or either it's going to be 2. This short form you can just call it as DNF. Why we are going with this one is to reduce the time complexity, because if you just write sort and do this, some test case will pass, but some test case is going to throw an error. It's going to throw an error, the time limit exceeded because of just calling for this sort. But if you use this, your time complexity will be reduced, because the sort is probably, let's assume it's going to perform quick sort. Quick sort is still n into log n times, but this DNF will solve the problem in the complexity of O of n by 2. Sorry, not n by 2, O of n times. So in big O of n, you can just sort it. I mean, you don't have any algorithm that sorts an array in big O of n, but it is possible if array contains only three data, either 0 or either 1 or 2 or 2, 3, 4 or anything, but it should contain only three data. In that case, this algorithm can be used and your question can be solved. So how this algorithm basically works is simple. Let's see. Let me put a space in between. So this algorithm is going to contain three pointers. Let me just remove this. Fine. So this algorithm contains three pointer. Why three pointer? Because of three data. So let's take this is a left pointer, and let's take this is the mid pointer, the intermediate pointer. And then let's take this is the rightmost pointer. So now what happens? This intermediate pointer is responsible for checking all the data. So you can see left is at the leftmost end, and let's say middle is pointer just moves in the middle to compare the data. So it just goes like this, and then it just goes. Sorry, it just goes like it just moves between left to right, and it's going to compare all the data with just 3 pointer. What's the purpose of n is? M is pointing towards 0. Next time onwards is to point towards 2 and point towards 1. I mean 0 again and 1 again and 0 and 0 again. Like this. It's just moving to 1 by 1, starting to end. So now let's just say I told you zeros supposed to be on the because L is a left pointer, R is a right pointer, and M is the mid pointer. So mid pointer always indicates the middle value. What's my middle value according to the sorted array data? Middle value is going to be 1. And the left pointer data are going to be 0. And the right pointer data are going to be 2. See, 3 pointers for 3 data. So left pointer data are always 0. L indicates 0. Let me write this one. So L pointer is for 0 data, all the 0 data. The middle pointer is going to indicate all the middle data, which is 1. And the last right pointer, it's a pointer for indicating all the data, which is 2. So you should make sure this rule follows. L should be always 0. L data should be 0. R data supposed to be 2. And the mid data always should be 1. Make sure this rule follows. If it is not following, then all you need to do is swap the data. So let's compare. So we can see M is pointing towards this. So M is 0, right? So 0 supposed to be where? 0 supposed to be at the left side, not in the right side or not in the middle. 0 supposed to be in the left side. So what you're going to do is just M data, swap it with the L data. Why are swapping it? Because 0 supposed to go to left side. And if 2 is present, it is supposed to go to your right side. If 1 is present, we don't have a problem at all. Because 3 pointers for 3 data. So you can see M is 0. So what happens? Swap it with your left pointer because 0 supposed to, L should be supposed to pointing towards 0, right? So I'm going to swap this. So middle pointer will become 1, left pointer will become 0. After doing this, one data is moved to its position. So now what happens? Once one data is moved to its position, increment your L value. So L value will be incremented to second data. Why? Because we found the M data as 0 and it has been moved to the L, like 0, like M is like 0 is not my data, 0 is left data. So I'm going to swap my data with my left data. This has been swapped. Now we can see M. So M data is 1. So M is pointing to 1. We don't have any problem at all. We don't need to worry because M is supposed to be 1. So if M is 1, we don't have a problem. Just move and check for the next data. So now you can see next data is going to be 2. So 2 supposed to be on the right side, right? But it's not supposed to be in the middle. 1 supposed to be in the middle. 0 supposed to be on the left and 2 supposed to be on the right. So now what I'm trying to do is I'm trying to swap this data. This is 2. 2 is not middle data. So middle says right data. It just says that 2 supposed to be on the right. So swap it with your right data. So now what happens? You can see left and right both are 2 and 2. After swapping also it will become 2 and 2. So after swapping what happens? If the data is swapped, if I take this data and if I swap with this data, what happens? Last data is fixed. So what happens to R? R will be decrementing and R will be pointing towards 0 now. Now again check. You can see again M is 2. So what we'll do? Okay, M is not my data. Again I'll try to like 2 supposed to go to your right. So again I'm going to try. So I'm going to swap this M data with my right. So right data will become 2 and the 0 which was here will go to this. Now again take your M data. See M data supposed to be 1. If it is 1, no problem. But now it's 0, right? So 0 supposed to be swapped with left data. All the 0 move it towards left. All the 2 move towards right. So now we have left. Left is over here, which is 1. So M and left, because why I'm going to left now? Because of 0. 0 is supposed to go to left. So swap these two. So I'll swap this and this will become 0. So after fixing the second data, what you'll do? L pointer increments. And R pointer was over here. Now M pointer is, check your M pointer. M pointer is 1. So 1 we don't have problem. If it is 0, push it to left. If it is 2, push it to right. But now your M value is 1. You don't have any problem. Go to the next one. So I'm going to next data. So next data is going to be 0. 0 in the sense it's supposed to be pushed to the left side. So I'm swapping this with my L data, 0. So third data is fixed. Move your L pointer forward. And R pointer was over here. Now check your M data. Your M data is 1. Don't have a problem at all. Move it. Now again check your M data. 1. We don't have a problem at all. If it is 0, we need to swap it with left. If it is 2, swap it with right. Now we don't have a problem at all. Once if you're swapping with left data will be incremented. If you're swapping with right data will be decremented whenever you swap. So right data is this. After swapping, if you try to swap, what happens? L data keep on incrementing for every swap, and R data will be keep on decrementing for every swap. So now this is simple. MS pointing towards 1, and now increment again. So now you can see R and M are in the same index. So all you need to do is simple. Until M reaches this R point, keep on checking with the data. If the data is 0, swap it with left pointer increments. If the data is 2, swap it with right pointer decrements. Until when? Until these 2 pointers meet in the same index. So this idea, let's try to code. Let me just keep these data for my reference. Fine. Left pointer, mid pointer, right pointer. So left pointer is 0. Mid pointer also start from 0, because we can start from last index as well, because both is mid pointer is going to move from left to right. So right pointer is going to be length of the array minus 1. Why minus 1? Because of index values. So 3 pointers are done. Middle is going to start from left until it reaches right. So how can you write the condition for that? While middle pointer is less than equal to R, because mid should go from left towards right. Done. Okay. Now check if array of that mid value is equal to 0. If it is equal to 0, we don't have a problem at all, because mid value is supposed to be, if it is 1, because left is 0, right is 2, and mid value is 1. If it is 1, we don't have a problem at all. So M plus equal to 1. Just increment your M value. Now, LF array of M data is 0. In case of 0, what happens? 0 is supposed to go to the left side, but 0 is in the middle. 0 is supposed to be on the left side. And if you get another LF of that middle data is 2. If it is 2, what happens? Swap it with right data and right will decrement. And if it is 0, you have to swap it with left data and left data will increment. As you want, once you swap, move the pointers one by one. The pointers will get closer. From now, left and right is far away. Once you swap, it will get closer, one step, closer, one step, closer, one step for every swap data. So now we'll swap because M is equal to 0, right? So 0 data is supposed to go to left side. So array of left, comma, array of middle data, swap it. So array of middle with array of left. So these two will swap those data present in the array. After swapping, what happens? One data has been swapped right. So L plus equal to 1. L will increment. And also M will be incremented. M is equal to 1. Why? Because Middle value is the value that you swap. After swapping it, you don't need to worry about middle value. Check for the next data. Now, go for m is equal to 2. If m is 2, what happens? That should be swapped with right. So array of right, swap it with array of middle data. Now, array of middle data, swap it with array of right. This will swap middle and right because 2 is supposed to go to right. After swapping right, right gets decremented by 1 because as L moves forward, right will be decrementing. So now this loop will keep on going until M and R meets the singular point in the same index. If that is happening in the sense, all the data are sorted. So after doing this loop, let's try printing that array data, taking out the square brackets. So put a star over there. Fine. Okay, let me run this. Okay, input, initial input. Forgot how many data did I give? 1, 2, 3, 4, 5, 6, 7. Okay, 7. And I need some input. Where's my first input? Yeah, it's going to be 1, 0, 2, 0, 1, 0, and 2. I'm pressing enter. See, now you can see you get your output, which is sorted. Simple. What's the difference between this and using a normal sort is some test case might fail because of time complexity. That will take more time. This will take a lesser time. Okay. Okay, that's it for today. And there is a link which is pasted in the description. And kindly just go and look at that form. What is that form? So that is the form where you will be. Let's just fill that form where you will be getting a test, a mock test, based on like a mock test based on these questions. So make sure that you fill the form which is given in the description. And yeah, if you just like this video, like it and share and subscribe. Fine. So tomorrow we'll come up with a new set of questions.